Good morning, guys. Welcome to March 26th, a nice review day. Our aim, what do we need to master about the equations of parallel and perpendicular lines? Hopefully you got a chance to fill in some of these do now questions. Alright, but here are your answers. Parallel lines and their equations have same slopes. Parallel lines, same slope. Perpendicular lines and their equations have opposite reciprocal slopes. So remember, find the slope, you're going to flip it and change the sign, either positive to negative or negative to positive. Number 3, when finding the equation of a perpendicular bisector, we must use opposite reciprocal slopes and also find the blank as the xy point to substitute into y equals mx plus b form. Right, that would be the midpoint. So the lines are perpendicular, opposite reciprocal slopes, but more specifically it's a bisector this time. The point we know that the bisector passes through is the midpoint. Alright, so you use that midpoint formula. Number 4, when a dilation occurs, the corresponding sides are parallel and therefore have the same slope. Now the lines, remember this two scenarios yesterday, the lines could be parallel or the lines could be the exact same line. The equations are exactly the same if the center of dilation is a point that's on the line. Okay, but if the center of dilation is a point off the line, usually the origin, the lines end up being parallel. Okay, so we're going to look at 8 review questions. Right now in the video, I'll go through 4 of them with you. We've been practicing a lot of the algebraic skills for a lot of these questions. What I'm going to do is show you in GeoGebra how you can answer these questions today. Alright, when you go through them on your own, you're more than welcome to do either way, GeoGebra or the algebraic way. Okay? So what is an equation of a line that is perpendicular to the line whose equation is 2y equals 3x minus 10 and passes through negative 6, 1. So I'm going to graph that equation, alright, the initial line, 2y equals 3x minus 10. Okay, also going to plot the point, which is negative 6, 1. Alright, and let's see out of our answer choices, alright, what's going to be perpendicular to the given line and pass through that point that we have there. So choice 1, okay, you can see we have y is equal to negative 2/3 x minus 5. Okay, so what we should notice here, guys, perpendicular, but does not pass through that point that we need. Okay, negative 2/3 x minus 3. Alright, so you can see that that's our answer choice, y equals negative 2/3 x minus 3. It passes through that point, negative 6, 1 that they gave us, and it's perpendicular to the initial line. Alright, let's just quickly look at one of the answer choices that would be wrong. Y equals 2/3 x plus 1. Alright, definitely not perpendicular, you can see that. Okay, and if you put in choice 4, you'll see that's also not our answer. Okay, so you end up with choice 2. Alright. Number 2, what is the equation of the perpendicular bisector of the line segment shown in the diagram below? Alright, so our perpendicular bisector now. So not only does the line have to be perpendicular to the given line, okay, it has to bisect it, so it has to pass through the midpoint. Alright, so let's plot the segment into GeoGebra. I'm going to use the points tool, point and plot. Now connecting it to sort of make it a segment, the only way we can really do that is underneath lines. It says vector. So vector, and then connect the 2 points. Okay. And now let's graph our answer choices. We'll see which one's the perpendicular bisector. Y plus 2x equals 0. Alright, so turns out it's just an extension of that line. Hopefully you're thinking some sort of dilation, alright, of a point. Alright, the center of dilation would be a point on the line. Okay, that would be that scenario. Not what we're looking for here, but just a scenario that we saw yesterday. Y minus 2x equals 0. Alright. Looks close. Probably not our best answer choice. I'm not sure if those are perfectly perpendicular. Now, if you were unsure, you could check the slopes, and you'll see that they're not opposite reciprocal slopes. 2y plus x equals 0. Alright, once again, not perpendicular. Choice 4, hopefully it's that. 2y minus x equals 0. Alright, you can see that that is perpendicular to the initial line. Alright, if we took out the answer choices that were wrong, you can see it's definitely perpendicular. You could check the slopes, see that they're opposite reciprocals, and it also does pass through the midpoint, and at this point the midpoint is the origin. Okay, but yeah, that's our answer choice, choice 4. Alright, number 3. Which equation represents the line that passes through the point negative 2, 2, and is parallel to y equals 1/2 x plus 8. So this was our first distance learning lesson. Alright, dealing with parallel. Same idea, parallel to a given line and passing through a specific point. Alright, so let's graph the initial line and the point it has to pass through. Okay, and our point, negative 2, 2. Choice 1, y equals 1/2 x. Parallel, doesn't pass through the point we need. Alright, so I'm going to go right to choice 3 here, because I see it has the same slope. Alright, right? Parallel line, same slope, so 1/2 is our slope. It's in slope-intercept form. Okay, choice 1 was a potential option. Alright, choices 2 and 4 are not. Okay, those have the opposite reciprocal slope. So if I graph choices 2 and 4, which you can do, you'll see that those are perpendicular. At this point, it has to be choice 3, y equals 1/2 x plus 3. Let's just confirm. Alright, so is indeed parallel and passes through that point that we needed. Okay, so choice 3. And finally, choice 4. Number 4, rather. What is an equation of the image of the line y equals 3/2 x minus 4 after a dilation? Okay, so now yesterday's lesson, dilation of scale factor 3/4 centered at the origin. Alright, now dilations, we should be thinking about parallel. Alright, dilations, parallel. all right, you could see the equation they gave us is in slope-intercept form. Y equals 3/2 x minus 4. So that tells us our slope. Our slope is equal to 3/2. All right, think about what that eliminates. 1 and 2. Those do not have the same slope. Okay, so now we need to determine, look at choice 3, y equals 3/2 x minus 4. That's the exact same line. Okay, and then choice 4, y equals 3/2 x minus 3. The first one, when the line doesn't change, just for a little repetition of yesterday, y equals 3/2 x minus 4. The line does not change when the center of dilation, okay, is a point that's on the line. All right, and for choice 4, all right, y equals 3/2 x minus 3, the center of dilation would have to be some random point that's off the line. All right, then the y-intercept would change. Remember, we'll multiply that y-intercept by the scale factor. Okay, so it's the origin. All right, y equals 3/2 x minus 4. Let's graph it. It's our initial line. Okay, so you can see the origin, the point 0, 0, is not a point on the line. So the line is going to change. The y-intercept will change. All right. So if we graph choice 3, it's going to be the exact same line. That would be if the center of dilation was a point on the line. All right, so this y equals 3/2 x. Let's see how we got choice 4. We would take the y-intercept, remember, and we'd multiply it by the scale factor. And that would indeed produce choice 4, which is y equals 3/2 x, same slope, parallel lines, minus 3. All right, -4 times 3/4 is -3, so we would indeed get choice 4. All right, let's take a look at that in GeoGebra. All right, parallel lines. Dilations, parallel lines. All right, good stuff. So you're going to give numbers 5, 6, 7, and 8. All right, give those a shot. You're more than welcome to do it algebraically or with GeoGebra, whatever you feel more comfortable with. They're all multiple choice. Okay, and check back in later on today for the answer key in the content library. Message me on Remind if you have any questions at all. Have a wonderful rest of your day, and I'll see you mañana.